Hello class, this is the video for section 3.6, derivatives of logarithmic functions. And the learning objectives are find the derivative of logarithmic functions, okay, and then apply log or logarithmic differentiation. We'll call that's like log. And there's a difference between the two, and these two will show how. There are certain functions that you can never use any of the rules that we have learned directly, unless you use simplify it before applying them. And that's what we'll call the logarithm or log differentiation. All right. Now, in case you have forgotten the log functions, that if I have log 8 base 2, it means that what must I raise the 2 to get 8? And that is 3. And so the answer is what? 3. This is because, okay, 2 raised to the third is equal to what? 8. Now, if I have log 8, log, say, 16 base 4, right? The answer is 2 because what? 4 squared is equal to what? 16. That 4 is there. Over here, the 3 is what is there. Okay. Now, these are the graphs. Okay. The green for log base 2, blue log base 3, and red is pink is log base 5, and then base 10. That's the black one. So as you increase the base, this is getting what? They all pass through the point 1, 0, but it gets narrower and closer toward the x-axis. All right. Now, these are the definitions to differentiate any function, a log function to the base b. Using definition 1, it says that it is what? 1 over x, okay? 1 over x times the natural log of the base, that is the b. So this b is the base over there. And then if it's natural log of e, all right, remember, if you have natural log of x is equal to the same as log x base what? Base e. So that, remember, that's why we have, if the natural log of e, we say this is equal to 1, because log e base e, the log of a number with the same base is equal to 1. So log 10 base 10 is equal to 1, all right? So the second definition is that you have a natural log of x. This is what? Is it just equal to 1 over x? Because, right, you had 1 over x times natural log of the e, but the base is what? E. And then natural log of e is what? 1. That's why I guess what? Just 1 over x. And the third definition is that if you have this x, or the x's we have here is not just x or 1x, but you have, say, 2x, or you have what? X squared plus 4, something like that. How do you differentiate that? That's where the chain rule comes in. That's why the chain rule comes in. And so when you have that, it's the same thing. If you have natural log of e, u, it will be what? 1 over u, okay? Then times the natural log of what? E, times what? The du over what? Dx. And then, of course, natural log of what? E is what? 1. So you get this expression right here. Okay, right? So, or you can say that the natural log of a g of x, it's going to be 1 over what? The g of x, okay, times the derivative of what? The g. And that will give you what? G prime of x over g of x, like that. Let me change the color. It's better this way. G prime of x divided by g of x, like that. Okay, so, but if I have something like, if it is not e and it's like 10, so if you have like something like log of u base 10, okay, what would that be? this is 1 over what? U times natural log of 10 and times du. Okay, we're going to see example in a minute. In the next slide, actually. Okay, so here's the example. Exercise number what? Number 7, using the definition 3. Okay, remember the base is 10. So in this case, my f prime of x is equal to 1 over what? Over this whole thing, because that's a log. 1 plus cosine of x, all right? Then times natural log of 10, well from the 10, that's the base. Then this time the derivative of 1 plus cosine of x. You differentiate that. Now, what is that? If you differentiate this, you get what? 0 plus what? Minus sine x. And this will be 1 plus cosine of x times natural log of what? Natural log of 10. That'll be answer. Here's another example that is in terms of the natural log. This will give me what? That is equal to 1 over this expression, sine x, then times chain rule, times what? The sine of x, the derivative of that. And the derivative of sine is what? Cosine of x. So that goes to the numerator. You get times 1 is cosine divided by sine x. And then this is the same as the cotangent of what? All right. The next example, actually next example. Now we want to talk about the logarithmic of differentiation. Okay. There are certain functions that you cannot use. For example, if you have y is equal to e to the x. Okay. X is a variable, it's not just a rational number. So you cannot use the chain rule. You cannot use the power rule here. This is not equal to x raised to x minus 1. No, it's not, because it is not. X is a variable. It's a function of its own. All right. So in this case, this is where this is very important. Okay. Now, but we want to review certain properties of log. Okay, log properties, and it works for this log to the base 10 or base 2 or base any base, and also the natural log. So I have it in terms of the natural log, that if you have natural log of a product of two things, they become the sum. And natural log for the quotient, it becomes what? The minus. And then if you have natural log of a raised to n, the n comes to the front and multiply by natural log of what? A. We call this is the power what? The power rule. Okay. Now, like I said, it works for also what? Log to any base, not just what? Base 10. All right. So here's the steps. Okay. The steps in doing this, doing the logarithmic or differentiation. First, take natural log on both sides of the equation and simplify. Okay, simplify means that you use these properties that we just talked about here to simplify your expression that you get. Step 2, differentiate what? Implicitly with respect to x. And then you solve for what? Y prime or dy dx. Okay. All right. So don't forget the power rule. If you have a function x raised to n, it just equal to what? N x raised to n minus 1. But if you're using the chain rule, multiply by this, the derivative of x times x, and that goes with 1 times this is the same. Okay. So now let's take some examples. All right. Now for this particular example, I am going to do it in 2 ways. I'm going to solve it using the approach that we just talked about. And also the second approach will be looking at it. This is a product of two functions. So I'm going to use the chain rule, the product rule combination with what? The chain rule. Okay, so in problem, I'm going to do it in 2 ways. Now, I'm going to solve it and simplify it all the way to the end. in both cases so that we can compare and see that they are the same. But you don't have to simplify it. That's your homework. Sometimes they just, once you finish the step 3 in log differentiation, you stop there. Okay. But in this case, I will intentionally solve it and simplify it to the last bit, so that we can compare and see that whichever approach you can use to find the derivative of the equation. So let us go to the steps, right? I'm going to divide this into my page into 2. Now, step 1 says what? Take natural log. Take natural log and what? And simplify. Take natural log and simplify. And write it well. Natural log and simplify. So we take natural log on both sides. So the natural log of y is equal to natural log of x squared plus 2 all squared, x to the 4 plus 4 all to the 4. Okay, so if I simplify, no, this is product. So I can use the log properties to write as a sum. So that's what we mean by simplify. So natural log of x squared plus 2 raised to 2, then plus natural log of what? X to the 4 plus 4 raised to what? Raised to 4. Okay, we haven't finished. We got to go further, because this will go to the front. That is what? 2 natural log of x squared plus 2 plus 4, because of this 4 here, times natural log of x to the 4 plus 4. So now we have natural log of y equal to that. So we have taken natural log on both sides and simplified. Now, step 2, it says what? Differentiate. Differentiate implicitly. Differentiate implicitly. So we're going to differentiate this step here. Remember, y is a function of x. As you can see, that was your y. So you use a chain rule. If you differentiate natural log, you get what? 1 over what? Y, then times y prime. Okay, is equal to, now if you differentiate this, you have what? 2 times 1 over x squared plus what? Plus 2, right? Then times the derivative of x squared plus 2, which is what? 2x, plus 4 times 1 over x to the 4 plus 4 times what? 4x what? X cubed. So this gives me 4x, that is 2 times 2x, divided by x squared plus 2, then plus what? 16x to the third, divided by x to the 4 plus what? Plus 4. Okay, and you have 1 over y times y what? Y prime. So step what? Step 3 says that solve for what? Y prime. Now, if I'm solving for y prime, I'm going to multiply through both sides by what? Multiply both sides by what? Y. So we're going to multiply this by y and multiply this whole thing by what? By y. Now, if I do that, this y will cancel out, and then we have what? That's what we're going to have. This is, so you have y times 1 over y, y prime, equal to y times 4x over x squared plus 2, then plus 16 x to the third divided by x to the 4 plus 4. Okay, now this y's will cancel out, so then your y prime is equal to the y, but we substitute it back. My y is right here, so that is what? X squared plus 2 all squared, x to the 4 plus 4 all to the 4, then times this expression here, 4x over x squared plus 2, then plus what, 16x cubed over x to the 4 plus what, plus 4, like this. Okay. Now, I could stop here, and that will be my answer. Okay, I could stop right here, but this will be my answer. Okay, in your homework, most of them, that's where they stop. Once you substitute the y back into the expression, you stop there. But I'm going to go all the way to the end so that you could see that when we simplify it, the both expressions are the same. So then we're going to write this as what? Okay? We want to keep this x squared plus 2 all squared in the x to the 4 plus 4 all raised to what? 4. Then what is this expression here? Okay, to have the common denominator will be what? X squared plus 2 then times x to the 4 plus 4. Then the numerator here will be what? The 4x times this denominator, which is what? X to the 4 plus 4 and plus 16x cubed x squared plus what? Plus 2. So we want to multiply that. Now this is equal to, well, before I even go further, this will cancel one of this, and that will cancel also one of that, and you'll have with 3. So then you have x squared plus 2 times x to the 4 plus 4 raised to the 3rd. Okay, now let's simplify. This will be 4x to the what? To the 5th plus what? 16x, then plus 16x to the 5th plus what? 32x what? Cubed. All right, then what is in this parenthesis will be what? This is 4, this plus that is what? 20x to the 5th plus what? 16, sorry, let's put the 32 first. 32x cubed plus what? 16x. Okay, so you have this, and then that's equal to x to the 4 plus 2, x to the 4 plus what? 4 all cubed. But as you can see, we can pull out what? Okay, 4 is common to 20, 32, and 16, and then x also. So let's bring out 4x squared, sorry, 4x out. Then this will be 5x to the 4 plus what? 8x squared plus just 4. Then times these two expressions there. X to the 4 plus 4, and then x squared plus what? Plus 2. All right. So the final answer will be what? 4x squared plus 2, x 4 plus 4 raised to the 3rd, and then 5x to the 4 plus what? 8x squared plus what? Plus 4. So this is my what? Y. When I simplified it all the way what? To the end. Okay. Very good. So now I'm going to do the same. That's a lot of work. See? You know why? It's a good word. No, it's correct because I did it. Okay. Anyway, let's go to the next one. The same question, but I'm using what? The product and the chain rules for here. Okay. So if you use the product rule, because this is a product of two functions, we have what? Y prime or dy dx is equal to, keep the first one, x squared plus 2 all squared, and differentiate this using the chain rule, which is 4x to the 4 plus 4 raised to the 3rd times the derivative of that, which is what? 4x cubed. Then plus, okay, plus you keep the second one and differentiate the first. So x to the 4 plus 4 and raised to what? 4. Let's differentiate that. We have what? 2 times x squared plus 2 raised to 2 minus 1, which is 1, And then we have what? The derivative of what? X squared plus 2, which is just what? 2x. Okay, so we can look for common factors and pull out some things there. Well, over here, this will be 2 times 2x is what? 4x. Okay, and then we have x to the 4 plus 4 all raised to 4. And then x squared plus 2 on this side. And over here too, you have what? 4. Actually, 4 times 4x cubed was 16 x cubed. And then we have x squared plus 2 all squared, then times x to the 4 plus 4 raised to what? 3. Okay, all plus, we add them together. Okay, now what are the common factors there? Okay, the common factor is 4x outside. Okay, we have this factor and that factor also. This is 4. Okay, but it's 1, so we put one of them. So x squared plus 2. And then this one we put 3 of them because this is higher, this is smaller. Exponent is 3. So we get x to the 4 plus 4 raised to the 3rd. Okay, then what is left there? If we pull, we have 16x cubed and we pull out what? 4x. We're left with 4x what squared. Okay, then times one of these. That is what? X squared plus 2. Then plus, then that will be left with just one of those. So x to the 4 plus 4. Okay, so now let's simplify it again. 4x, x squared plus 2, x to the 4 plus 4 raised to the 3rd. And what is left there? That is 16, sorry, not 16, that is 4x squared, x to the 4, plus 8x squared, plus x to the 4 plus 4. Okay, now look at that. This is what? 4x plus, that's what? 5 for x to the 4 plus 8x squared plus 4. And then you have what? 4x, x plus 2, x to the 4 plus 4. All. Look at this expression right here. Okay, it's multiplying anyway. Look at this expression there and compare with what we got at first. Look at it carefully and look at what is here. Same thing. See that? Same thing. So I've shown you that if I use the what? For expressions like this, if I use the product rule and the chain rule, as I can also, or if I use the logarithmic word differentiation, we all get the same thing. Okay. For such, you can have 2 ways, but not all the time. Okay, you will see. This one too, I can use the quotient rule and the chain because of the way it is. Because this expression here is nothing but what? X minus 1 over x to the 4 plus 1, all raised to what? 1/2, right? Then I can use what? The chain rule to do that. But I'm not going to do that, okay? I'll just stick to the log differentiation. So we use the log what? Differentiation to do this. Even though, like I said, I can use the chain rule and then the quotient rule to do that. So we will let, because f of x, let y equal to what? F of x. Okay, so then my y is equal to what? X minus 1 over x to the 4 plus 4, all raised to what? 1/2. So step 1, take natural log on both sides. Take natural log on both sides. So you have natural log of what? Of y is equal to natural log of x minus 1 over x to the 4 plus 1 all raised to what? 1 half. So now use the laws to simplify. The half comes to the front times natural log of what? X minus 1 over x to the 4 plus 1, like that. That's natural log of y. So then what do? Guess what? I finished simplifying. So this is equal to 1 half natural log of what? X minus 1, okay, minus what? Natural log of what? X to the 4 plus what? Plus 1. But I can distribute the 2 1 half over, okay, which will give me this. Let me use this one. So now I have natural log of y is equal to 1 half natural log of x minus 1 minus 1 half natural log of x to the 4 plus 1. So step 2, differentiate implicitly. Okay. Differentiate implicitly. Differentiate implicitly. Okay. So that will give me 1 over y times y prime is equal to differentiate that implicitly, you have what? 1, the 1 half times 1 over x minus 1 times 1. If you differentiate x minus 1, you get 1. Minus, they have what? 1 half times 1 over x to the 4 plus 1. Then times the derivative of x to the 4 plus 1, which is what? 4x cubed. Okay? So then if I write this will be what? 1 over 2 x minus 1. Then minus the 2 will cancel 2, 4 equal to 2, with 2x cubed over x to the 4 plus what? Plus 1. So then I have 1 over y prime. So then step 3, it says solve for, which in this case you multiply this by y and multiply the whole thing by what? By y. So when you do that, this will cancel that and you have what? Y prime is equal to the y times 1 over 2 x minus 1, then minus 2x cubed over x to the 4 plus 1. Okay, all into what? In parentheses. However, sorry, I need to take some, my throat is dry. Okay, my y is here. It's equal to f of x. So substitute that back. This will give me the square root of what? X minus 1 over x to the 4 plus 1, then times whatever I have there, 1 over what? 2 x minus 1, then minus 2x cubed over x to the 4 plus what? Plus 1. And that is my y. That's where we will stop. I'm not going to simplify it further. Okay, so we'll leave it like that. That's good. All right. Now let's consider last example. Now, this is what I talked about, that for the first 2 examples, the last 2 examples that we did, we could see that we could use other means, other approaches, either product and chain rule or quotient and chain rule. However, in this case, none of those work because the function is not multiplying, it's an exponent of another function. So the only way is what? The logarithmic what? Differentiation. All right. So again, we go to the steps. I'm just not going to write the full step. The step one is that you take the natural log on both sides. You have natural log of what? X raised to sine of what? X. What you will simplify, you have what? Sine x times natural log of x, and you have natural log of what? So then step two, we differentiate implicitly. That will be 1 over what? Y times y prime. That is equal to, if this is a product, don't forget. So there's the product rule. And so that is keep the sine of x and multiply by the natural log of x, which is 1 over x times 1. Then plus, we keep the natural log of x and multiply by the derivative of sine, which is what? Cosine of 4x. So you have sine of x over x because of this over 1, then plus natural log of x times cosine of what? Of x. Then you have what? 1 over y times what? Y prime. So step 3 says that solve for what? Solve for y prime. So the trick we have been using is that we multiply through by what? Okay, multiply through by y. We can say that multiply through by y. So that gives me y times 1 over y prime, the left hand side, and then have y times sine x over x plus natural log of x times what? Cosine of x. Okay, but what is my y? Go back right here. So this y's will cancel, therefore your y prime is equal to x raised to sine of x times sine x over x plus natural log of x times what? Cosine of x. And that is our what? So with that, we come to the end of this section 3.6. I'll see you next time. Take care. Bye-bye.